I must say I'm very excited to be here today and to tell you a bit more about what we do at Aerobotics. My name's James Patterson. I'm the CEO of Aerobotics, a company that we started 4 years ago here in Cape Town. And at Aerobotics, we help tree crop farmers solve their pest and disease problems. And we do that by using machine learning algorithms to gain insights from drone and satellite imagery. We're really pushing the boundaries of technology use on the farm. But before we get into our technology, I'd like to take you through a brief history of how technology has progressed on the farm. So it started off 10,000 years ago, where we started using mechanical tools, just hand tools to farm small plots of land, grow food for ourselves and our small communities. In the 1900s, came the mechanical era, and this made a big difference to agriculture because farmers could now farm much larger areas of land using tractors and combine harvesters. In the 1950s came the chemical era and then the biochemical era, which saw the introduction of fertilizers, which meant farmers had to spend a bit more money on the inputs, but they could generate a lot bigger yield at the end of the season. And we're now at the digital era. And what's exciting about this digital era is it's no longer about spending more money on your inputs. It's about using data and technology like machine learning to gain insights and really start farming a lot more efficiently. And in this digital era, it's now possible to monitor and track each individual tree on the farm. This tree over here has been reconstructed using our software from drone imagery. In the past, for a farmer to cover a piece of land of 50 hectares, checking each tree like this for pests and diseases would take a full day. With drones, it's now possible to do this in 20 minutes. Using our algorithms, we can find problems at a very early stage on a tree-by-tree basis. We then use this data to guide the farmer into the field to those exact trees that have a problem, using our targeted scouting application. When the farmer collects data in the field, that feeds back into our models, continuously retraining and improving them. This is an example from one of our real clients. On the top left, we see a drone image, a small part of an orchard. Now, I grew up on a farm like this, a citrus farm, and when you're standing in between these big trees, you really only see 4 or 5 trees on your right and 4 or 5 on the left. So this imagery here gives you a much bigger picture. What we then do after the drone has collected the imagery, we run it through our models, which identify each individual tree and calculate the canopy and outline of each tree. Within that, we then run our pest and disease models and show the problem trees to the farmers in red. So very simple. The farmer can then use our scouting application to find those exact trees in the field. And in this case here, the photo on the left is one that has been taken using our scouting application. And the problem is mandarin starch accumulation. So this feeds back into our models. And where this adds a lot of value to farmers is instead of not detecting this tree, having it die, and waiting 5 to 6 years for a new tree to come into production, we can detect this problem early, and the farmer can get back into production the next year. So there are 3 major technical considerations we take into account when building our technology. The first is performance. We deal with a lot of data on a daily basis, and our clients are generally in remote areas with poor connectivity. So it's important for us to build high-performing technology that's delivering a good experience to the client. The second is reliability. We need to be able to scale from 10 to 100 to 1,000 farmers on a daily basis while keeping the system stable. And finally, agility. It's important for us to build and deploy products in a fast, agile manner. We've leveraged various AWS services to make this possible. We house all our data on S3 and then serve this data to our clients around the world using CloudFront. We've recently moved from a monolithic to a microservices architecture, leveraging EKS. This means that our products are now able to auto-scale dynamically. And finally, on the agility side, we've set up continuous integration and continuous deployment, meaning that our software developers and data scientists can work independently in containerized environments. Just some recommendations if you're trying to build technology using these products. I think it's very useful to learn the benefits of each product before you start so you can really use them efficiently, and to build your products for scale from a very early stage. Now, with our focus on tree crops, one of the big metrics we track in our company is the number of trees we've processed through our platform. And now that the underlying technology is scalable and the processing is automated, we're pushing ahead to get to 40 million trees by the end of the year. Some updates on where the technology is going. We're currently solving problems on a tree-by-tree basis, but using the drones to get in a lot closer, we'll start doing leaf-level analysis. So with this, we can identify insect damage, we can identify insects themselves, and very early stages of disease. So using this technology, our goal is to help tree crop farmers stay in control of the pest and disease management. Thank you.